Hello students, welcome to the online lecture series of St. Andrews Institute of Technology and Management, Gurugram. Myself Satinder Vats, Assistant Professor in Etce Department. In this presentation we will see about adders and subtractors, which is a part of Unit 2nd of Digital Electronics in Etce 4th semester. So let's start with the half adder. So half adder is a combinational logic circuit which adds two input bits. So it has two inputs and two outputs. One output would be the sum of the two bits and the other would be the carry generated out of these two bits. So half adder circuit is designed to add two single bits or the binary bits A and B. It is the basic building block for addition of single bit numbers. Okay, this circuit has two outputs, carry and sum. So sum would generate the sum of two bits, and if there is a carry generated from the summation of two bits, it would be given as carry out. So this is the block diagram of a half adder having two inputs A and B and two outputs sum and carry. So for A and B, there are four combinations possible: 0 0 0 1 1 0 1 1. And if I take the sum of these binary digits, for 0 0 it would be 0, for 0 1 or 1 0 the output would be 1 and the carry generated would be 0 0. But in the third case, when both the inputs are high, the sum would be 0 and there would be a carry generated, that is 1. So if I write down the logical function of sum and carry using this truth table, you can see for sum, here I am getting two highs against these combinations, which are a bar b plus ab bar. So this would be my sum function, and carry is high only at one combination, that is a and b both high, so it would be a into b. So I can implement it using gates. So you all know that this is the equation of a XOR gate, exclusive OR gate. So this would be my sum function implemented using the XOR gate having inputs A and B and output as XOR B. Similarly, at C I need to use a AND gate, which is nothing but the product of A and B. So this would be my carry. So this is my basic half adder circuit. Now full adder. Full adder is developed to overcome the drawback of half adder because it cannot add 3 bits. It can only add 2 bits, and it cannot add the carry generated from previous addition. So in full adder it can add two 1 bit numbers A and B and also add the carry with them. So full adder is a 3 input and 2 output circuit. So two inputs are A and B, that is the bit 2 bits, and C in is the previous carry. So it will generate sum and carry out of these 3 bits. So for 3 inputs I would be having 8 combinations possible, and for all of these I have write down the sum and carry generated against them. For first case it would be 0 0, for second it would be 1 and 0, for third it would be 1 0. If I have two ones, then the sum would be 0 and carry would be 1. And if I have all of them 1, that is 1 1, so it would be 0 and carry generated would be 1. So this carry would add to this 1. So in this case, that is when all the inputs are high, the sum would be 1 and the carry would be there as well. So if I write down the logical function of the sum and carry and simplify them, so it comes out to be that for sum it would be A's or B's or C in, that is the carry. It is as exclusive OR function of 3 bits. And for carry, I would get A into B plus A into C in plus B into C in, which can I implement using these XOR and OR gates. So for sum it would be a XOR gate. At inputs we have A, B, C, and the carry we can generate using 3 and 1 OR gate. So this is my full adder circuit. So if I have more than one bit in the numbers to be added, so I will require more than one full adder. So if I need to add n bit numbers, that is A0, A1, A2, B0, B1, B2, so for 3 bits I would require 3 full adders. So to add 2 n-bit binary numbers, we need to use n-bit parallel adder. That is, it uses a number of full adders in cascade. Cascade means in series. So carry generated from one full adder would be feed it to the carry input of the next full adder. So carry output of the previous full adder is connected to the carry input of the next full adder. For example, if we have a block diagram of a 4-bit full adder, whereas the 4-bit numbers are A0, A1, A2, A3 and B0, B1, B2, B3. So it will add 2 bits at a time, that is A0 and B0 would be added first, and the sum would be come out of this first full adder, and the carry generated from this first full adder would be given to the second full adder, which will add A1, B1 and this carry generated. So the second full adder would give me the second sum bit, that is S1, and the carry generated again will be fed it to the next full adder. So this is how I will get the sum bits in parallel, whereas the carry would be fed it from one to another in series. So in this block diagram, A0 and B0 represent the LSBs of the 4-bit words A and B, that is least significant bits. Hence full adder FA0 is the lower stage, and therefore its Cn has made permanently 0. So we can take this C0 as 0 if I am starting my addition from this full adder. So carry generated from first would be feed it to the full adder 1 and so on. So we get the sum parallelly from 4 full adders. So this is how an n-bit parallel adder would work. Then we have half subtractor. So we would subtract one digit from the other. So in half subtractor there would be the difference of 2 digits only, as we were doing in the half adder. So in this, if I am subtracting B from A, so A would be my minuend and B would be my subtrahend. If I am subtracting B from A, so A would be my minuend and B would be subtrahend. So I have made the truth table in which 4 combinations are possible for 2 inputs, and the difference bit, that is this one, it would be, if I subtract 0 from 0 it would be 0. If I subtract 1 from 0 it would be 1 with borrow 1. If I subtract 0 from 1 it would be 1 0, and if 1 is subtracted from 1 there would be 0 and no borrow. So when I write down their logical function, so borrow would be A bar B and difference would again comes out to be A or B, as was the case in adder. So the difference is here, that is in the borrow only. Difference is same as the sum, that is a XOR gate is used, and for the borrow it would be A bar B. So now if I have full subtractor, that is it is a combinational circuit with 3 inputs A, B, C and output difference, and C dash is my borrow generated, or C is the borrow from the previous input. So when I write down the if I write down the truth table for FullSubtractor, in which I having three inputs, that is A and B I mark digits, and C is the previous borrow. So the difference A minus B minus C would be this one, you can see in the truth table, and this will be my borrow generated. So I can write down the function as D is equal to A XOR B XOR C, which is again same as the full adder, but the difference is in the borrow. It would come out to be, if I simplify the C function using this truth table, it comes out to be A bar C, where C is the previous borrow, plus A bar B plus B into previous borrow C. So I can again implement it using the XOR gate, AND gates and OR gate. So this is a very simple function. You need to remind the truth table how the difference is generated. So this is it for the basics of adder and subtractors. In the next video we will see carry, look ahead adder and BCD adders. So thank you very much.